Welcome back, I'm so glad you're here. Today we will review for the C certification exam from the C++ Institute, which I'm certified in. Preparing for the exam will allow you to expand your knowledge about C while being able to show your certification on your resume and online. In this video, we will go over what is on the exam, how to prepare for the exam, and how to take the exam, and then go over sample review questions. The timestamps are in the description below, so let's get started. The CLE exam from the C++ Institute is a great way to show your C skills. And this exam is 30 questions. The first 4 questions cover basic concepts such as the print statement and the main function. The next 4 questions goes over data types, evaluations, and basic input and output operations. Data types include integer, floating point numbers, characters, hexadecimal, and more. Evaluations, greater than, less than, and basic input and output operations like printf and scanf. The next 4 questions are in arithmetic, logical, and bitwise operators. And then you have 4 more questions on decision-making statements, including the if statement and switch statement. Then there's 5 questions on loops, which include while loops, do while loops, and for loops. Then you have 5 questions on arrays, pointers, and memory management, including malloc and free. Then 2 questions on string manipulation, and finally 2 questions on functions. And the full syllabus can be found at this link posted in the description below. If you want to do some practice, the C Essential Part 1 course is great and walks you through this step by step. It is a free course consisting of 5 modules, and you'll be able to go from knowing nothing about C to being fully prepared for the test. You can also review it for this exam by watching my previous YouTube videos, and you can see a playlist in the description below as well as up above. And the videos include creating your first C program, creating variables, having user input, creating comments, making an if statement, while loops and do while loops, for loops, switch statements, functions, pointers, arrays, malloc and free, and typecasting, bitwise operators, and multi-conditional statements. And if you review these videos, this is another great way to prepare for the exam. So now you may be wondering, how do you take the exam? Well, the exam is $59, but there's a sale online once every 3 months. For example, there's a spring, summer, fall, and winter sale. So look out for that. And you can purchase it at this link, which is found in the description below. And the passing score is 70%, and you take it online, and it's not proctored. And once you are fully prepared, you can take this exam, and it's a great way to review while showing your skills on a resume. So now that you have an overview of the exam, let's go over some review questions. And these are going to start out with simple concepts and move into harder concepts along the way. So, what is the English language? Well, it's a natural language. That's the type of language that you speak. A programming language is C. It's code that you type, and the computer compiles a programming language like C into a machine language which consists of ones and zeros. What is a high-level language? A high-level language is a type of programming language, very similar to the first question. C is a high-level language. A compiler is a computer program designed to translate programs from a high-level language, like C, into a machine language, which is ones and zeros. The data type int is, well, it's an integer number. The type char is character, float, float, double, double, and as you see here, int is integer. Is this name a valid string? This is the name of the variable. Well, it has capital letters, which is fine, and lowercase letters, which is also fine. You just can't have spaces or special characters, and you can't start with a number. So this can be used as a valid variable name. How about this? 101 Dalmatians. Well, it's not a valid variable name because you cannot start a variable with a number. What is the value of the var variable after the following snippet of code? Well, var is initialized to 100. Then var equals var plus 100. So it equals 100 plus 100, which is 200. Then the final line of code, var equals var plus var. And var was 200, so var now equals 200 plus 200, which is 400. And that is the answer. What is a keyword in C? It is a word that cannot be used in the meaning other than defined in the language standard. For example, if is an if statement. You cannot use if as a variable name. A comment placed anywhere inside the code is a syntactic equivalent of a space because C does not read spaces, just like they don't read comments. What attributes does a variable have? Well, it has a type, for example, integer, a name, for example, sum, and a value, which you set it equal to, for example, 5. Which is a proper integer number? Well, an integer number can't be a decimal number, and in C you don't have commas, and you don't have underscores, so a valid integer number is 1, 2, 3, 4, 5, 6. Is the following integer valid? Well, 08 is not a valid integer because you cannot start an integer with leading zeros in C when setting it equal to something. What is the value of the following integer? Well, 0x8 is hexadecimal 8, so this is valid, and 8 in hexadecimal is just 8 in decimal, so it's 8. Which of the following strings is a valid integer name? Well, the first one looks right because you can have underscores, which is totally fine, but let's look at the other three. The second is wrong because you can't have a space in a variable. The third is wrong because you cannot have a special character. And the fourth is wrong because you cannot have a dash. Which of the following is an invalid variable name? Well, underscores are fine, but remember you cannot have a variable with a leading number. So 0 underscore is incorrect. Is this valid? Well, you cannot have two variables with the same name. Here it says create an integer called variable and create another integer called variable, so this is not valid. What is the value of var at the end? Well, var starts out as 2, then var equals 2 times 2, which is 4, then var equals var plus 4, so 4 plus 4 is 8, and then var equals 4 divided by var, so 8 divided by 8 is 1, and then var equals var modulus var. and modulus is the remainder. So 1 mod 1, that divides evenly, so it has no remainder, so the answer is 0. This is very similar, but look, it has a comment, so you don't do the last two lines. So var equals var times var, which is 2 times 2, which is 4, and var equals var plus 4, 4 plus 4 is 8, and C doesn't look at the comment, so the answer is 8. Which is a floating point number? Well, floating point number is a decimal number. So 123.456 is a decimal number. What's the floating point equivalent of 8765 e to the negative 2? Well, e to the negative 2 is times 10 to the negative 2, so move the decimal 2 places to the left, and you get 87.65. What is the value of x at the end? Well, x equals 1 divided by 2. You might be thinking 0.5, however, look, it's an integer. So 1 divided by 2 is an integer, it cannot have a decimal, so integers automatically round down, so they round down to 0. What is the value of x? Well, x equals 1 divided by 2 times 3, and it's an integer, so 1 is an integer divided by 2 is an integer, is 0. 0 as an integer times 3 as an integer is 0. So don't be fooled by this, it is still 0. How about this? Float x. And here's the key difference. You have 1 point, so that means 1 is a float divided by 2 is an integer, is 0.5 is a float, times 3 is an integer, is 1.5 is a float, so your answer is 1.5. What is the value of the variable k? Well, I is 4, j is 5, then minus minus I, that means subtract 1 from I is now 3, so 3 times 5 is 15, and that is your answer. How about this? You have 4 and 5, now you have plus plus j, so you're adding 1 to j is now 6, 4 times 6 is 24, and 24 is your answer. What is the value of k here? Well, I is 3, j is negative 3, k is 3 times negative 3, which is negative 9. Negative 9 plus equals j, so negative 9 plus negative 3 is negative 12. Negative 12 divided by 3 is negative 12 divided by 3, which is negative 4, and negative 4 is your answer. What is the value of c? Well, c equals backslash. Well, remember, backslash is an escape character. So if you want c equal to backslash, you need to have backslash backslash. And in this case, you would only have 1. So it thinks you're escaping the quote sign, which will cause an error because you're not creating a program correctly, and this causes a compilation error. How about this? C is equal to A, but now we subtract a space. Well, when you subtract the space from a lowercase letter, you are subtracting 32. And if you remember ASCII, you're just converting a lowercase letter to an uppercase letter when you subtract the space, so you're going to get a capital letter A. And that is your answer. In the next question, we have I equal to 3, j equal to negative 3. And then, is I greater than or equal to itself? Yes, that's true. So that equals 1 plus j less than or equal to itself. That's true. So that's 1. Is I equal to j? Well, 3 is not equal to -3, so that's false. 0. And then, is I greater than j? Well, 3 is greater than -3, so that's true. So 1 plus 1 plus 0 plus 1 is 3, and 3 is your answer. What happens when you run this program? Well, I equals 2, j equals -2. If this is true for any non-zero number, so I minus minus, so now I equals 1. And then if j, that's true, so j plus plus, so j equals -1. And then k is 1 times -1, which is -1, and that is your answer. How about this? I is -1, and j is 1. If I subtract 1 from j, j is 0. If j, that's not true, so we'll go right to k equals I times j, and since you're multiplying it by 0, the answer is 0. How about in this case? Well, you have if j is 0, so that's not true, so we'll go into the else statement and add 1 to I, so I is equal to 1. If I, that's true, so we'll subtract 1 from I, and so I is now 0. And then since if was true, we don't go into the else, then k equals I plus j, which is 0 plus 0, and your answer is 0. In the next question, we have I equal to 2, j equal to 3. If j, well, 3 is not 0, so it will go into the if statement. So j minus minus, j now equals 2. So we'll finish with that if statement, so we don't go into the else if or else. So I and j are now 2. If j, we're subtracting 1 from I, so I is now 1. We're finished with that. So then k equals 1 plus 2, and that is 3. And that's your answer. Next question, we have a double x, which is -0.1. Then we have an integer I, which equals x. Well, an integer can't have a decimal point. Well, since I is an integer, it can't be a decimal point. And since it's a negative number, you're rounding up, so I is gonna be 0. In the next program, you have both floats and integers. So this question is important to follow order of operations and types. So x times y is a float times a float. 1.5 times 2, both as floats, gets you 3 as a float. 3 is a float plus I divided by j. 2 is an integer divided by 3 is an integer will give you an integer 0. So 3 is a float plus 0 is an integer will give you 3 is a float. So it's 3 is a float which has 8 decimal points after it. The next question is very similar, yet you have typecasting. So your x times y is same as before. 1.5 times 2 as a float is 3. And then float I converts 2 as an integer to 2 as a float. So 2 is a float divided by 4 is an integer. A float divided by an integer is a float. So that will give you a half. So 3 is a float plus half is a float is 3.5, and that is your answer. Next question. You have I equals 1, and in this case you have a while loop. we'll multiply I times 2 until I is not less than 16. So 2 times 2 is 4. It will continue inside the while loop. 4 still less than 16. So multiply by 2. 8 is still less than 16. Multiply by 2. 16 is not less than 16. So we'll break out of that while loop and print out 16 as our final answer. In this question, we have I and j both equal to 1. And then, while I is less than 16, we're going to add 4 to I and 1 to j. So I is 5, j is 2, 5 is less than 16, 5 plus 4 is 9, j is 3, 9 is less than 16, 9 plus 4 is 13, j is 3, 3 plus 1 is 4, 13 is less than 16, add 4 to I, and j is now 5, and since I is greater than 16, we're going to break out, and your answer is going to be 5. How about in this program? I7, j is equal to I minus I, which is 0. So while we're going to divide by I by 2. And since I is an integer, 7 divided by 2 has to be a whole number, so it's going to be 3. We're going to add 1 to j. J is now 1. 3 still true. 3 divided by 2 must be an integer, so we'll get 1 for I and add 1 to j. J is now 2. And then I is still 1. 1 divided by 2 is 0. Add 1 to j. J is 3. While 0, that's false, so it breaks out and prints j as 3, and that's your answer. Question number 40. Well, not I. So because it's not I, it will only enter the while loop if it's 0. So the while loop never even happens, so we're going to print j right away as 0, and that's your answer. Next question. I's 11, and while i's greater than 0, we're going to divide it by 3 and add 1 to j. So j is going to be 2 the first time, and then 11 divided by 3. Rounding down, we'll get 3. 3 is greater than 0. Add 1 to j. J is now 3. 3 divided by 3 is 1, which is greater than 0. So we'll add 1 to j and now have 4 for j. And 1 divided by 3 is 0, so it's going to output 4 for j. Next question, for loop, I is equal to 0. We'll stay inside the for loop as long as not I, so I is equal to 0. Then we will increment I by 1. So 0 lets us go into the for loop. 0 will now iterate to 1, and j will iterate to 1 as well. And then 1's not 0, so we'll end this for loop, and j is 1. Next question, I is 1, j is -2. 4, colon, that's another way of saying for forever. We're going to do this until we break out of this. So I times 3. So 1 times 3 is 3. J plus 1, so j is -1. I is not greater than 30. So I times 3 is 9. And then -1 plus 1 is 0. 9 is not greater than 30. And then 9 times 3 is 27. Add 1 to j. J is now 1. 27's not larger than 30. So 27 times 3. And then add 1 to j to get 2. And now I is greater than 30. So we'll break out of this for loop and get the answer to be 2. How about this question? We have and statements and or statements. So we'll do and statements before or in terms of order of logical expression. I is greater than 0, that's true. J is not greater than 0, so that's false. So true and false is false. Then let's look at the right side. I is less than 0, that's false. So false and true is false, so false or false is false. So K is false, which is also 0, so it's gonna output 0. I is greater than or equal to 0, that's true. So true or something else, we don't even have to look at the rest because the first part's true. True or whatever is always true, so it's gonna output 1 since 1 is true. I is greater than 0, that's true, but we have a not, so that makes it 0. So then 0 or, and then we'll combine these two since it has an and. It basically has a parentheses around at the beginning of the first one and the end of the second one. So is J greater than 0? That's false. Not false is true. True and I is less than or equal to 0. That's false. Not false is true. So true and true is true. And because it's false or true or something, that means it's true, so it's going to output a 1. Next question, we have I is 1, J 0, and here we have bitwise operators. So 1 and 0, that's just 0 in terms of bits, so K is now 0. So K, and then K, we're changing it by not K, and 2 knots are the same as 0 knots, so we're changing it by 0, so we'll still get 0. K equals not I or J, and not I is false, or J, which is false, is false. So K equals not false, which is true, which is 1, and 1's your answer. In the next question, we have an exclusive OR. So I exclusive OR J, that means only one can be true, but not both, and that's true, so 1 plus. Not I, 0, exclusive OR J, so 0. So 0 exclusive OR 0 is 0. So we have 1 plus 0 plus I or not J. And because both of those would be true, and it's an exclusive OR, it evaluates to false. So true plus false plus, and not I exclusive OR not J is true. So true plus false plus true is 2 statements that are true. In the next question, we have bitwise operators. And it's important to note that bitwise operators, in terms of order of expression, come after addition and subtraction. So in this case, we'll add 1 and 1 first. So 1 plus 1 is 2. So then we'll have I, which is 0, and we'll shift 0 to the left by 2, and then shift it to the left by 0. So in terms of bits, it's 8 bits for I, so it's 8 zeros. And when you shift to the left, you'll just add on zeros at the end, and you'll still have all zeros. So I will be all zeros at the end, so you'll just have 0. And then the next question, I is equal to 3, and j is equal to I minus 2, which is 1. And then we have a switch statement, I minus 2, which is 1. So this will fall into case 1. So we'll add 1 to j. J will now be 2 but there's no break statement, so it's going to fall into all the other cases until you have a break or end. So it's going to fall into case 2, j is now 3, fall into case 0, j is now 4, and we break out of the switch statement, so your answer is 4. How about this program? Same setup as before. However, I is 3, so this time you'll default j equal to 0, then you'll fall into case 0, so you'll add 1 to j and then break. So your answer is 1. How about the next problem? In this case, we have an array, and we have t of 0 equal to 0, and we're gonna start indexing it 1 and go up to 5. So t of 1 is equal to t of 0, which is 0, plus 1, since I is 1. So t of 1 is 1. How about I equals to 2 now? T of 2 is equal to t of 1, which is 1, plus I, which is 2. So 1 plus 2 is 3. So t of 2 is 3. How about I equals to 3? We have t of 3 equal to t of 2, which is 3, plus I, which is 3. So t of 3 is going to be 6. So t of 4 equals t of 3, which is 6, plus 4, which is 10. And we output 10, and that's our answer. How about this program? T of 4 is 0. I is equal to 3. Well, I is greater than or equal to 0, we'll subtract 1 from I. So t of 3 is equal to t of 4, which is 0, times I, and 0 times anything is 0, so t of 3 is equal to 0. So now I is equal to 2. T of 2 is equal to t of 4, so that's 0, so t of 2 will be 0, same with t of 1, same with t of 0, and so your answer will be 0. How about this program? T of 0 is 1 and t of 1 is 0. So you're printing this long value. So you just have to eliminate them one at a time, working from inside out. So at the beginning you have t of 0, which is 1. So at the beginning you have t of 0, which is 1. Now you have t of 1, which is 0. Now you have t of 0, which is 1. So you just have to work from inside out. You have t of 0, which is 1. Then you have t of 1, which is 0. Then you have t of 0, which is 1. T of 1, which is 0. And finally, t of 0, which is 1, and 1 is your final answer. Next question. You have I equal to 2, while I is greater than or equal to 0, subtract 1 from I. So t of 2 is equal to 2 minus 1, which is 1. So now you have t of 1. T of 1 is equal to 1 minus 1, which is 0. And then finally, t of 0 is 0 minus 1, which is negative 1. And then at the bottom, you have t of 1, and that's equal to 0. And then you'll subtract whatever in the parentheses. t of 0, that's -1, plus t of 2 is 1. -1 plus 1 is 0. So t of 0 is -1. So t of 0 is -1. And you have 0 minus -1, and that's equal to 1, and that's your answer. Question 57. I is equal to 0, well I is less than 2, add 1 to I. So t of 0 is equal to t of 3 minus 0, which is 3. And t of 3, remember indexing starts at 0, so 0, 1, 2, 3. So t of 0 is equal to 8. And then t of 1 is equal to t of 3 minus 1, which is t of 2. So that's equal to 4. And then I is equal to 2. That's not less than 2. So we're going to print t of 2, which is 4. And that's your answer. And then in your next question, you're solving for s. And you have a for loop starting with I equals to 2. So s plus equals t of 2, which is 2. So 1 plus 2 is 3. And then you're incrementing I by I plus 1. So I is now equal to 5. So 3 plus equals to t of 5. And 3 plus 5 is 8. And now you're finished with your for loop, and your answer is 8. Next question. You have 4 characters, and you're finding what t of 1 minus t of 0 plus t of 1 minus t of 2 is. Well, t of 1 minus t of 0, those letters are only 1 apart. So in terms of ASCII, the difference is only 1. So t of 1 minus t of 0 is 1. Plus t of 3 minus t of 2. And b minus a, the difference of that in ASCII is also 1. So you'll have 1 plus 1, which is 2, and that's your final answer. And the next question, you have t of 0, which is 1, plus t of 2, which is 1 times 10 to the second. So that's plus 100, and then plus 1,000. So your answer is 1,101. Next question, I is equal to 1, and now we have a pointer here. The pointer j will have the value of I. K will store the value of j. So in a sense, k, I, and j are all storing the same value. And when we dereference it, we're going to get 1. What is the value of this program? Size of t. T is a character that has 3 places, and a character is a size of 1. So the size of t is 3 minus the size of t of 0, which is 1. So 3 minus 1 is 2. Next question, size of t, and t is 6, but it's an integer, so it's 4 bytes. So the size of t is 6 times 4, which is 24, divided by the size of integer, which is 4. So 24 divided by 4 is 6, and 6 is your answer. In the next question, you have the pointer p equal to t, which is the start of the array, plus 4 places. So let's move it over 4 times. And then we're gonna have p plus equals star p. So move it over 5 times. So we'll get it to store the location of 10. Now when we dereference it, we get 10 is the answer. In the next question, we have the pointer p located at t. So that's located at this one right here. Then we're going to iterate p by 2 places. So now it has a length of 2. So we're going to iterate p again by p of -1, which is a net of 2 more places, and that's going to have the answer 5. How about the next problem? You have the letter A, then you want to add S of 3, which is 3. So A plus 3, and A plus 3 is just 3 letters over from A, so that's D. You want to print this string, the third index, so indexing starts at 0, so 1, 2, 3, so G, and then G minus 1, which is F, since that comes one letter before G, and that's your answer. How about this program? Well, we're copying the string A, B, C, D, E 2 places over, so A and B will stay the same, but then it's gonna be A, B, C, D, E again, so your full string A, B, C, D, E. So S of 0 is A minus S of 2 is A. So A minus A is 0, and your answer is 0. In the next question, we're concatenating two strings. This will basically output CABDE, CABDE. So S of 0 is still C, and S of 2 is still B. So C minus B, that gives an output of 1. And then the next question here, very similar. S of 0 will be A minus S of 2. How about the next question? We have a pointer P pointed at S plus 3, which is pointed at D. So the string goes DE ABC. So we're outputting P of 1, which is E, minus P of -1, which is C. So E minus C is 2. And that's your answer. How about this? You have pointer pointed at S plus 5. So that's actually pointing back at the beginning of the string, since the string only has a length of 5. So P of -1 is still E, and E minus star P minus 4. So E minus B is 3. How about this problem? Q is P minus 10, so loop back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the beginning of the string. Q of 14 is 4 minus Q of 13 is 3 is 1, because 4 minus 3 is 1. How about this string? We're going to iterate by 1 again, and then 1 more time. So a total iteration of 3, 1, 2, 3. So starting at 4, so it goes 4, 5, 1, 2, 3. So P of -1 is 3. How about this question? We have two for loops. We have S equal to 0, then we have I equals to 2, while I, we're going to subtract by 2, and j equals to 1, less than 2, we're going to increment I by 2. The nice thing about this is that we'll only have to increment s one time, because the for loops will end after the first time. So s plus equals t of I minus 1, so t of 1, j. So t of 1 of 1, so t is 2 by 2, so 1 of 1 is actually the last one here, since these two are the first row, these two are the second row, so 8's in the second row, second column, so s plus equals 8, s equals 8, and that's your final answer. How about the next question? S equals to 0, I is equal to 1 while it's greater than 0, subtract by 2, j is equal to 1 while it's less than 2, increment by 2, for k equals to 0 while it's less than 3, increment by 3. So this will only run once as well. And we're going to increment s by t of k, so k is 0, plus I minus 1, which is 0, and then j, which is 1. So 1, 0, 1 will give us 2, and that's our final answer. How about the next question? We have a pointer p, and then we're having malloc 2 times the size of integer, so this stores 2 integers in this pointer. So we're going to set p equals to 2, and then we're going to set the next value to star p, which is 2 minus 1. So you have two values, 2 and 1. So star p equals p of 1, and your second value here is 1. So your answer is 1. How about the next question? We have malloc again, and it's the size of t, so it's 4 integers. And then we have a for loop. And then we'll set p of 3 equal to t of 0, so p of 3 is 8. Then p of 2 is equal to 4, p of 1 is equal to 2, and p of 3 is equal to 1. So in a sense, we're flipping the array, and then we want the third value of p, which is 4. So 4 is our final answer. In the next question, we have malloc again, and we have two arrays. But it's important to note here that p of 1 is equal to p of 0. And because if it's a malloc, that means it's pointing the same place. So you have two for loops here. So p of 0, 0 will equal to 0 plus 0, which is 0. P of 0, 1 will equal to 0 plus 1, which is 1. P of 1, 0 will equal to 1 plus 0, which is 1. And p of 1, 1 will equal to 1 plus 1, which is 2. But remember, we replaced p of 0 by p of 1. So that's why p of 0, 0 is 1, because it's the same thing as p of 1, 0. And the next question is very similar, yet we don't assign p of 1 to p of 0, so we solve this issue so it's like normal. So p of 0, 0 will just be 0 plus 0, which is 0. How about this question? We're seeing if the sizes are equal. Well, star u is in parentheses, so this is actually the pointer, not the value. And the pointer is 8 bytes as opposed to 4, so the sizes of these are not equal. How about this? Well, this is fine because the parentheses around T10 is the same thing as no parentheses, so those two are equal. How about this? The size of struct s divided by the size of s, which is a structure, so this is dividing by itself, so s dot s is 1. We're looking for the string length of s dot q dot s. So s dot q dot s of 0 is A, and s dot q dot s of 1 is B. So because there's only two letters here and they're next to each other, the string length is 2. How about the next problem? Very similar. However, there is no s.q.s of 1, so it assumes it's a backslash 0. So it assumes the length is only 1 because it doesn't see the location of where B is. And those are some sample review questions for the CLE exam. If you want more practice, feel free to take the C Essentials course as mentioned earlier. The description's down below, and there's a good practice test at the end, and that very closely resembles what the actual test will be like. And feel free to let me know if you have any questions, and I'm sure you'll do great. Thank you so much for watching. If this video helped you on your exam, feel free to comment your success down below. Make sure to follow along with this video series by subscribing and hitting the notification bell, or by clicking on the next video so that you can expand your knowledge about C. And as always, I can't wait to see you next time.